Our discussion is about one hot encoding. So we all know, right? Machines understand in another way, but not how humans process, right? In language form. So that's why we have these kind of topics. So we'll convert here all the human language into vectors. First things first, why convert text into vectors? When we are working with text data in machine learning, we need to convert words into numbers because, as much as we would like, computers don't quite understand human language naturally. They need numbers to make sense of things. This transformation from words to numbers is crucial. And today we will explore one of the finest way to do this, that is one-hot encoding. So let me introduce you all to one-hot encoding. So what exactly is one-hot encoding? Imagine you have a pet parrot who can only understand the sequence of zeros and ones. Each word in your text is represented as a vector of zeros with a single one in the position corresponding to that word. This way, each word gets its own unique representation. So let's take one example. I think unnecessarily executed this. It's just for notes purpose. So our example is like simple one. Suppose we have these three following sentences: apples are sweet, oranges are tangy, grapes are juicy. Our goal is to convert these sentences into a numerical format using one-hot encoding. So we need to build vocabulary. Building vocabulary is nothing but we need to find all the unique words in our sentences. This is a theory session. Okay. So all the unique words are what? Apples are sweet, oranges tangy, grapes juice out of all three sentences. Okay. So we have total of how many unique words? This collection of 7 we have, and this collection of unique words is called vocabulary in this topic. Okay. So we will assign one hot vectors now. This is our representation. Each vector will have a length equal to the size of our vocabulary. If you see, all are 7 because we have size of vocabulary. Each vector, if you see, they are a length of 7, right? Here's how this is represented. If you can see, apples is first, so it has 1 at here. You can understand, right? Self-understand. Everywhere there is only one number only one time because it represents that word in the actual vocabulary. So let's encode the sentences. Oh no, Control Z is not working. Let me write again, but it's time waste. Actually, I have kept everything ready to save time and I only made a mistake. So this is a step 3. Okay, so let's see sentence 1. Apples are sweet. If we take only these three, this sentence is represented by these 3 vectors. That's how it works. So for each sentence, now we have a matrix, right? Where each row represents a word and each column represents a position in the vocabulary. For instance, the first sentence results in a 3 by 7 matrix. See, 1, 2, 3 and 7. Vertically 3, horizontally 7, right? Which means 3 words and 7 unique words in the vocabulary. You got it, right? So why use one-hot encoding? This is our next. One-hot encoding is one of the simplest ways to represent textual data numerically. It clearly indicates the presence or absence of a word in the vocabulary for each position in the vector. Definitely limitations will be there, right, for everything. So for one-hot encoding, limitations are high dimensionality, which is for large vocabularies, the vectors become huge, right, consuming a lot of memory. And second limitation, no sense of relationship. It doesn't capture any relationship between words. For example, sweet and tangy are both taste descriptors but are treated as completely unrelated in one hot encoding. Oh, again executed. text. Okay. So what's next? While one-hot encoding lays the groundwork for understanding how we can represent text numerically, it's not typically used in advanced NLP tasks due to its limitations. This leads us to more sophisticated techniques like bag of words, TF-IDF, and word embeddings, and many more. We'll go through some of them, which we'll discuss in future sessions. So to wrap up, we have learned how to convert words into numerical vectors using one-hot encoding, turning our simple sentences about fruits into matrices of zeros and ones. This fundamental concept is a stepping stone in the journey of making machines understand human language. And coming to the final thoughts, so NLP is an exciting field with endless possibilities as we continue to unlock the secrets of language and teach machines to understand us better, right? Who know what's next? Maybe one day our technology will not only understand zeros and ones. I mean, technology in the sense I initially gave parrot example, right? Will not only understand zeros and ones but also crack jokes with us, which is already happening. Now ChatGPT is cracking jokes, right? We are learning very basics now. So thanks for joining me on this session about one hot encoding. If you found this helpful, don't forget to like and subscribe to my channel. And let's meet in the next learning.